Hi everyone, welcome to the fifth installment of my Sovol SVO8 series, from early rumors to unboxing and setup. In today's video, I will give you a pile of tests and measurements about my close to production unit and a bit more advanced calibration tips for improving speed, quality and overall user experience with our SVO8. This is Gergo, and I'm so happy to have you here on Gergo Print 3D, the YouTube channel about my 3D printing adventures and DIY projects. Since last week's video, the SVO8 section has been opened in the wiki on sovol3d.com with new firmware and much anticipated Orca presets for ABS, PETG, and even TPU. They are nice to have, but they will need some adjustments, which I will show you in my next video. Let's use this week's video to fine-tune our printer. So today we will cover 5 main parts. I'll quickly talk about backups and firmware upgrade. Then we'll compare some of the physical characteristics of the SVO8 to recent Sovol printers. In the third part, I will run 3 self-tests to show how my near production unit compares to earlier test units. Then we will look at 3 other aspects of the SVO8 we can calibrate. And as a bonus, I will help you add new menu commands to the device screen for heat soaking and proper shutdown. So strap in, because this will be quite a ride. I had access to firmware 2.3.2 a bit earlier and have actually been using my printer on it from day 2, so what you've already seen of my printer in my previous videos were mostly running on version 2.3.2 already. Since then, I've updated to 2.3.3 that appeared in the wiki recently. Applying these updates couldn't be easier, though admittedly it could be a little bit more user-friendly. The first pain point is to choose our update package. The OU variant, however, is only for early test units, so most likely you will need the regular version. I checked and my printer came with 2.2.7, so after backing up the contents of the included USB drive, I just formatted it and copied the file Sovol update package 415.deb on it in its root directory. Please note that I also made a full backup of my eMMC, as shown in my unboxing and assembly video. In case anything went wrong, I have a previous working version to go back to. These firmware updates will overwrite any config file change you've made, so be sure to back them up as well using WinSCP, for example, so you can make selective restores after the update. Pause if you need help with the login options, and you will find the config files under Home Sovol Printer Data Config. You'll need to turn on the printer with nothing plugged into the USB initially. Wait for the main screen to appear and then plug in the USB stick and simply wait 90 seconds. So this is another tricky part. There is no indication or progress report at all. We just have to wait until the printer reboots. This could surely be made more user-friendly. If all goes well, however, the printer will reboot and wake up simply with the new version. Your Wi-Fi settings are retained, but everything else saved in printer CFG or modifications you made to macros.cfg are going to be lost. You can use mergely.com to selectively restore your modifications and redo Z offset calibration and the rest on the new firmware. Before going into built-in tests and calibration routines like shaper calibrate, probe accuracy or bad mesh, some of you asked for physical measurements of the printer, so here are 7. The stock tool head weighs just 378 grams with cover and 309 grams without the cover. There are already a number of upgrades available, from 3D Print Demon's inductive probe upgrade to Nadir's nozzle variants. Just know this is the starting mass that affects resonance characteristics and acceleration capabilities. For comparison, the SVO6 Plus extruder weighs 360 grams. The SVO7's optional cover brings it up to 411 grams. As mentioned earlier, my build plate seems to have a PEI painted backside, which sticks well to PLA and has a smoother surface than the official texture side. So I'm not totally sure if this was intended as double-sided or not. It measures 0.7 millimeters. I have to say, much thicker than the single-sided PEI sheet that comes with the SVO6 Plus, where the back is just stainless steel. Nothing sticks to that. It's noticeably thinner at less than 0.5 millimeters. Both my T300 and SVO7 Plus officially came with double-sided textured PEI sheets, which are similar in thickness to the larger build plate of the SVO8. Maybe the T300 being the highest quality of them all, though I'm not a fan of the alignment system that unfortunately is shared with the SVO8 as well. Those alignment screws in the back of the SVO6 Plus and SVO7 Plus are the most convenient in my opinion. As for the desk space requirements, without the back panel and its chamber cooling fan, we can currently push the printer all the way back to the wall, and since the bed is stationary here, it will only need a 54 centimeters deep desk, the distance to the front of the front feet. We'll see how the official panels are, but I'm thinking about moving the chamber fan to one of the sides so I can keep the printer pushed to the back wall. The printer's feet are also 54 centimeters apart, which will exactly fit on an IKEA LAC table, but when placed next to other devices on the desk, you will need to leave an extra 5-6 centimeters for the power plug on the left side and another 15-20 centimeters for the spool and its holder on the other side, unless you relocate or modify these. The stock height comes out to be 57 centimeters from the desk. Mine is raised by 1 centimeter to make room for the beefier fan at the bottom. And again, when you place the printer on a shelf, you need to make room for the spool and the spool holder. With a standard 1 kilogram spool, it will raise the printer's height to 80 centimeters. The nozzle heats to 300 degrees max in just about 60 seconds from room temperature, hitting 200 at 30 seconds and 250 at 45 seconds. These are amazing speeds. The mains heated bed is equally fast, going from room to 60°C in just over a minute, 80°C in 2 minutes, and reaches the maximum 100 Celsius in 3.5 minutes, though PID dampening reduces the power near the top. This is on par with my T300 and a lot better than the SVO7 Plus and much better than the SVO6 Plus, where it takes 3 to 5 times as long to heat the bed. I don't have one of those fancy heat mapping cameras, but measuring at different points of the heat bed, the surface seems to be the closest to nominal of my printers, and even the corners reach close to the set temperature. My earlier printers had significant temperature differences between the center and corners, with bed surface temperatures being 7-8 degrees cooler than the set values. Curious about power? The printer idles at 14 watts, peaks close to 1.2 kilowatts during heat up, then averages around 120 watts during printing. These values are very similar to the AC heated T300 and about 4 times higher than the power measurements of the SVO6 Plus or SVO7 Plus. Just keep in mind, heating up several of these printers at once is like powering an oven or water heater. Besides heating, we need cooling as well. While I replaced the controller cooling fan for a quieter option, the original extruder fan and part fans generate even more noise while printing. Until now, the auxiliary fan on my SVO7 Plus was the loudest, measuring over 60 decibels at 100% and 52 decibels even when set to 50%. The new SVO8 easily takes the trophy though, occasionally hitting 70 decibels during printing, also measured from 1 meter. If you want a quieter printer, the SVO6 Plus and the T300 are better options, though I made controller board fan upgrades on both and even upgraded to a 5015 blower for part cooling on the SVO6 Plus. So these measurements are not really comparable to stock models. As you might guess, the louder and stronger the fan, the better these printers handle overhangs and bridges. The SVO6 Plus comes with a cooling system that's really not quite up to the task for high-speed clipper printing. You will need to upgrade the part cooling if you go the clipper route. The SVO7 Plus does a bit better than the T300, but it's the SVO8 that really stands out in performance. This concludes the physical measurements I could do for you. Let me know in the comments if you need anything more. I just couldn't think of anything else that could be useful. The SVO8, of course, is capable of a number of self-tests and calibrations on its own. I recommend the following 3. 1. We can start with input shaper calibration. The accelerometer is built right into the print head, so it is as easy as issuing a command from the mini screen, where we will find it under the cryptic name Auto Calibrate. However, if you want to see the actual resonance graphs, you will need to call test resonances axis equals X and Y from the command prompt, and following each, you will also need to SSH into the system using the user and password Sovol and enter the instructions you see in my command window here. After doing these, shaper calibrate x.png and y.png will show up in the config directory, accessible from the machine page of your web interface. Similar to other SVO8 units, my printer generated a very clean graph for the x-axis, and even the y-axis chart turned out to be somewhat better than most early review units, though the recommended filter formula ended up being MZV, which is only the second best, as I learned. Please note your input shaper results will greatly depend on the desk you place your printer onto, the bed tensions, and the state of your pulleys and idlers. 3D Print Demon achieved major improvements simply by updating the feet to these TPU printed ones, though the stock feet on my device produced optimal results even with the 10mm razor I added to fit the larger fan in the bottom. Having access to these input shaper graphs will help you make modifications and see their effect on the performance of the printer almost immediately. But I recommend redoing the test with the menu command shaper calibrate from the device screen, as it will automatically apply the recommended settings based on the tests. Probe accuracy test was new to me. The printer carries out a number of repeated measurements with the inductive probe and give you a range value for the probe. Here you will be able to compare to my results. For the SVO8, the company opted for a much smaller probe than the M12 model they used in all their earlier printers. Of course, the weight reduction in the toolhead is always welcome, but the smaller probe seems to be a lot less accurate for generating bad meshes, and with this, our first layer consistency could also suffer. According to Klipper documentation, the range value must be less than 25 microns, 0.025 millimeters, for usability. You can see my test results here. They aren't so bad in my close to production device with a range of 16 microns cold and just shy of 21 microns after heat soaking. It barely fits in Klipper requirements. The problem is, while the print bed is heating up, materials expand at different rates, potentially causing slight variances in the height across the bed surface. This can lead to discrepancies in the probe readings, which in turn could impact the first layer adhesion and overall print quality. To mitigate this, it's important to allow the bed to reach a stable temperature before starting a bed mesh scan or probe accuracy test, and to conduct the test at the same temperature at which you will be printing. This is called heat soaking. I actually created a new menu command in the Prepare menu on the mini screen, which will heat the bed to a selected temperature and move the print head 5 mm close to the bed's surface. We should keep it there for a few minutes to warm up the probe. I will tell you about my macro collection and how you can get it at the end of this video. I'm planning to implement 3D PrintDemon's straightforward probe upgrade to significantly enhance the precision using an M12 probe from previous Sovol models. And when that happens, I'll make sure to update you in a video. Until then, there are other ways to improve accuracy, as you see with the following setting changes. Increasing the number of samples to 3, so the system can use the median instead of the more error-prone average method. And we can also change the probing speed and distance to further improve the precision. All these settings you can see on my screen, and I will include them in the description of the video. The third automatic system test is making an ABL bed mesh. Using the new probe settings, I did a full 81-point mesh, which shows a range of just 0.27. I think this is an amazing result for such a large bed. Normally, the start print macro is set up for adaptive meshes before each print, so this complete mesh only helps us compare the quality of our print beds. Next, I recommend doing the usual calibration procedures in Klipper. I did 3 of these as well, such as the PID tuning of the nozzle and bed heaters. This command is directly available on the device screen under the Advanced menu, and we should run it every time we make changes to the print bed or to the nozzle. It's all automatic and only takes a few minutes. Correct PID values will help the printer maintain more constant temperatures and will result in better print quality. The PID values are then registered in our printer CFG, so this tuning should also be carried out after any firmware updates. I also did an E-step or extruder rotation distance calibration using my handy extrusion ruler available on CALDS 3D. As we could already tell from the 3D Benchy, the stock settings result in slight under extrusion, which was confirmed by this test, where extruding 100 millimeters of filament only pulled in 97. With this rotation distance calculator webpage, linked from the description below, I adjusted the rotation distance in the extruder section of my printer CFG, saving the old default value for reference. For the last calibration test, I ended up designing my own Cali corner model, which can be printed in about an hour and provides an external and an internal measure point for each of the 3 dimensions. Taking an average of the 2, we can get a fairly accurate reading of the dimensional accuracy of the printer and determine if there are any systematic errors in the X, Y, or Z axes that need to be addressed. I found 0.5% of shrinkage in the X, Y, and a full % of shrinkage in the Z direction in case of the SVO8, but after printing the same model on my other printers, I found them to be tuned similarly. So I decided not to change any of them, hoping Sovol's own calibration methods are more precise. What do you think? Should I trust my measurements and retune all of my printers, or it's better to leave them stock? I think if I want to design modes for these printers for you to print, it's better if we all keep our printers in the stock settings. Important note, if you do decide to update the Z rotation distance, be sure to change all 4 values in your printer CFG, otherwise you will introduce tilting in the gantry. If you followed all these calibration tests, your printer should now be well tuned for even better, more accurate operation. I promise you my convenience macro collection. It's amazing how easy it is to add new commands to the mini screen with just a few lines in printer CFG. I already told you about the soak command I added to the prepare menu. I also added a Z height command to the tune menu, which appears during printing. This command is not really for changing the Z height, but to give us a way to monitor it during printing, since the tiny screen doesn't have this important information normally during prints. I also added a shutdown command to the advanced menu that will turn off heating, disengage motors, and turn on the part fans to cool the nozzle below 70 degrees. It will also turn off the LED lights and beep when clipper was properly shut down, and we can flip the power switch. The last command I added will let you save your Z offset if you fine-tuned it during a print, but we'll talk about that in detail in next week's video. You can add these all simply by including the file gp3d_macro in your printer CFG file. You can get a zipped version of this file from my Cult3D project, link in the description below. Extract the gp3d macro CFG and drag and drop it over your machine page of the web interface to upload. In the last step, add the line include gp3d_macro.cfg between square brackets to the top of your printer CFG, just below the other include lines, and restart or reboot your printer. How was your setup process? Have you done any of these tests yourself? Have I missed any important or interesting ones? Please let me know in the comments below. I hope to have a lively discussion similar to our earlier videos. Another quick way to provide feedback, of course, is by using the like and subscribe buttons. And thank you for using my affiliate links below when you make any purchases on the Sovol website. You get the best prices this way, and it also supports my work on these videos. Have you seen other videos in the series? Click here to continue with them, or as we always say, go print 3D. Thank you for all your kind support. It means the world to me and the Gergo Print 3D channel.